video, I'm going to discuss about text-based classification. So for this, we're going to use TensorFlow to build and train the neural network. And the dataset is going to be IMDb dataset from Hugging Face. And we're going to use NumPy for numerical operations. First, we're going to import the required libraries, therefore TensorFlow and Keras for model creation, NumPy and Pandas for data manipulation, and tokenizer and pad sequences to convert text into numerical input, and then scikit-learn for evaluation metrics. After so the dataset approximately has 25,000 training and 25,000 testing movie reviews, labeled as positive as 1 and negative as 0. So we're gonna convert the dataset into regular pandas data frames to make it easier to work with text and labels. So the train text consists of list of reviews and the train labels are 0 or 1, indicating sentiment. And then tokens are used for words not seen during training, therefore which are out of vocabulary. And fit on text builds a word index based on training data. And then text to sequence converts each review into list of integers representing word indices, and then padding is added to the end. Therefore, it ensures all reviews have the same size for batch processing. Make sure our labels are NumPy arrays, which is the format TensorFlow expects. And then we're going to define an LSTM model. So the embeddings here are turns word indices into dense vectors. The first return sequences, the second condenses them. So these are the two LSTM layers. Dense and dropout are used for regularization and feature transformation respectively. So finally, dense one with sigmoid is used for binary classification 0 or 1. And then we're going to compile the model. So binary cross entropy, which is suitable for binary classification, and ADAM is used for adaptive optimization. So after we are gonna train the model for tree epochs. After training, we are gonna evaluate the model based on the precision recall and F1 score and support. And then moving on to text classification based on Distilbert on AG News. As we discussed, we're gonna use TensorFlow for neural network training, and here we're gonna load dataset from AG News, and then we're gonna use pre-trained BERT models. Also, we're gonna use Matplotlib and CBOM for visualizations. So after loading the datasets, we're gonna convert them to pandas data frame to ensure labels are integers, and then we're gonna downsample the data for faster training. Since we have limited resources, so I actually used Colab for free version. And then moving on to, we can split the text and labels into training and validation sets using stratified sampling, the equal label distribution. And after that, we're gonna load the tokenizer for Distilbert, a smaller and faster version of BERT. And then the tokenization function basically basically converts the text to token IDs and adds the padding and translation so that we can process batch trace easily, and returns a TensorFlow tensor. So applies tokenization to both training and validation set. Then load the pre-trained Distilbert with a classification head predicting one of the four classes. And then we can increase for better accuracy as well. And we're gonna evaluate the model and we're gonna do sample predictions. So this is the input and respectively this is the output in which it categorizes this text line or line of sentence. Next, moving on to, we're gonna use multitask with Roberta. So here the transformer we're gonna use is Roberta, and the dataset we're gonna use is IMDb. Scikit-learn we're gonna use for splitting and evaluation. So after loading the dataset, we're gonna convert into data frame, pandas data frame, so that it has only integer, and we're gonna downsize the dataset so that it runs easily with limited compute. And then here we're gonna categorize such as short equal to 0, medium equal to 1, and long equal to 2. So the tokenizer converts the raw text into model ready item, item tokens, token IDs, and then the tokenization function ensures each review is tokenized padded to length 128 such that we can easily process using batch, and then the output is going to be tensor to tensors, and then we're going to train the model, splitting into training and validation, so keeping both sentiment and length labels together. Tokenizers, so the tokenized inputs tokenizes the text for both splits, and therefore we're gonna do Roberta's class token output, and then we have two finalites, one for sentiment which is binary, one for length category, three class which is softmax. So we're gonna run the training briefly. After that, these are the evaluation accuracy after training the model. So this is the sample input and this is the sample output. So next, moving on to text classification using custom LSTM and metadata input. So we're gonna load the dataset. So we're gonna use 85% for training and 15% for testing. Label pairs, and after training the dataset, so we're gonna use LSTM on tokenized text and dense layer on length input, and which concatenates both for final prediction. We're gonna use binary cross entropy and accuracy, and gonna run for one epoch. So since we have limited compute, so these are the model accuracy and test loss, and this is the predicted class plus actual class condition matrix. So these are the scores of various Pearson and X scores.